Alright guys, we have some things to do. Now I spent some time last night and this morning modifying my resume. So things have been changed there. We can cross off a few things. We'll have some lunch soon. I want to work on a tutorial before possibly doing Leetcode. As an aside to what I'm currently doing. Just because I want to space out more of these learnings, especially since I want to get through quite a bit of tutorial content. And the reason why, I'm doing these tutorial contents is because they'll be helpful for me when it comes to the exam. Okay, now ideally what we can do by today is perhaps, these lectures we can probably skim through this lecture, but then we could skim through these two lectures actually. Scheduler development will come at some point. This tutorial we will do after we do policy iteration reward shaping tutorial after lunch, ideally. But I think that's the plan. Alright. So, I guess before I even start, let us do a monkeytype once again. Just so we can always, consistently, every day, work on and improve our typing skills. Ooh. Not bad, 50 words per minute. Words per minute, yeah. Question, exclamation mark. Not bad. Hello, Yorichi-san. Welcome, man. Do one more and we'll do some stuff. Ooh, that was the best so far. That was the best so far. I'm gonna do just a normal English. 450k. Not bad. Okay. Okay. That's pretty good. Alright, I am spending a little too much time on this, but I'll change it back to C++ now, I think. Alright, we'll do C++ the next time that we are on it. Okay. Now, the main concern is now the game theory question, the policy iteration. I guess with respect to the game theory, I can just reread this for a little bit and just make sure that I remember this. Make sure that when you add values to the normal form game matrix, you ensure you understand the problem statement. In this case of the tute, there was understanding that recurve bids are taking the value of the second bidder. The difference between weakly and strongly dominated strategies can be understood in if A chooses, then B would. Pure strategy, Nash equilibrium states are found from the previously determined best actions. Mixed strategy is a probability distribution and isn't the same action every time. You can find the mixed strategy probability such that the expected utilities for all actions in the set of pure strategies have expected utilities left equals expected utilities right for row player, or expected utilities top and bottom for the column player. Hello Georgeville, welcome again. I'm back, and this time quite a bit later. Policy iteration and reward shaping is going to be interesting. I got to do this well. Policy iteration versus value iteration. This is interesting. This distinction. Thought you weren't showing up today. Yeah, nah. I'll show up any day. Especially during exams, you know. But yeah, no, this morning I had to do some miscellaneous tasks. So it wasn't really worth sharing. You know what I mean? But I would have liked to start it earlier, to be honest, you know? Because now we're almost midday through. And it would just mean less practice time for me, you know? Definitely. So policy iteration. So policy iteration has a finite number of steps. Value iteration could have infinite. So it has a finite number of iterations, whereas policy iteration can theoretically require infinite iterations. Okay, so the policy iteration, where you have a Markov decision process, M, that is a tuple of the rewards, the probabilities of an action from state to state S prime, the action, the starting position, and the set of states. The output is a policy pi. So the step v pi to arbitrary value function, e.g. v pi s, is equal to 0 for all s. Step pi to arbitrary policy, which is equal to action A, for all s where A is an element of the action space, is an arbitrary action. All right. So if I were to imagine what this looks like, right? A value function for the policy is all set to 0. It's almost like a dictionary in this case. Then you set the pi. Hold up. Mum wants me to do something. So turns out I have lunch now, so I'm gonna eat this first. I'll be back in about 30 minutes. Alright, I'm back. Do you have note templates? I don't usually use the Obsidian note templates, no. Prime of S. RS, AS prime. Gamma V pi S prime. Okay, problem is, will I remember this? I'll remember it. Look at this enough times to remember it. Alright, so pi S, S prime S, some R, S, A, S prime, plus gamma V pi S prime. Plus gamma V pi S prime. V pi S and V pi S prime. V pi S and V pi S prime. v pi s The Maroon Knight. Thank you for the kind words. I appreciate you too. Hello, Akshat. screen went black. It's alright. Suarez. Shoot. Suarez shoots. Suarez shoots, then it's going to be a little bit different. And in the sense that if Suarez shoots, we're going to have 0.6 and 0.4. I'm gonna reload this. Hello RYO for joining the Discord. It's reopening Obsidian. Okay, 0.6.4. -2, -2, plus 0.8, 0.8. Now scored, so it's going to be C or messy, which is going to be A. So that's the second equation, and then the third equation, V pi. Eric Lopez, do you post your lives? I mean, they're always in the archive on my YouTube channel. So you can always go to I think there's a live tab on my channel. You can see them all. I'm pretty sure. And scored. Scored will always be return, which is always going to be C. It's always going to be Q pi of scored and return, which is going to be equal to 1 times the reward 2 plus 0.8 A. And we can solve these systems of linear equations. I think that would work. So Now to solve those systems of equations, I'm gonna find myself some room here. Probably just on the side. Eric, so what plugin is that? This is Excalidraw that I'm typing on, or writing my notes on. So I'm writing my notes on my iPad and then they get updated on Excalidraw there. And that uses a different extension called self-hosted live sync. But I've told people that I don't recommend using self-hosted live sync. Regardless, that is Excalidraw that you can see on my screen right now. So the equations of interest are A equals -1 plus 0.8b, B equals 0.6 of -2 plus 0.8c plus 0.4 of -2 plus 0.8a, and C, which is equal to 2 plus 0.8a. If that's the case, we can just all make it in terms of A. We'll just do it. So A is equal to -1 plus 0.8 of 0.6. Should I simplify B first? Yeah, I will. I'll make B simpler. So B is equal to 0.6 -1.2 plus 0.4248 C plus or minus 0.8 plus 0.32a, which is equivalent to -2 plus 0.48c plus 0.32a. I know I can just solve systems of linear equations. I could just do that without all this calculation. However, we'll just see it through this time. So A is this, B. Now B is 0.48c plus 0.32a, and 0.48c, well, we can extend that, so 0.48c is equal to 0.48 of 2 plus 0.8a. We're going to say 0.96 plus 48 by 8. Yeah. So 0.48 by 0.8. 0.384a. So now everything is in terms of A. We can find what A is. Plus 0.8 This is annoying. I could have just solved systems of linear equations, man. I'm gonna just do it. Solve systems of linear equations. Gotta pull out a different calculator. It has no battery. It has no battery. Never mind. As an alternative, we're just going to solve systems of linear equations online. Equation 1, 2, 3, 4. Well, lucky we only have 3 equations. So we're going to have these 3 equations. -1 plus point AB. Point 0.6 C and A. And then C is equal to 2 plus 0.88. Oh, okay, so it's in fraction form, but alright, that's fine. -4 point, that seems right. Yeah, that is right. For -4.194. -3.993. That's for Suarez. And then score to -370, -273, 1.355. Yeah, for the scored. Epic. Epic. Okay, so that I can map. Okay. Man. So now I have those values. The last two technically unknown values. How do you get them? I'm gonna copy this solution. Or, no. Load. Update. It should update. Yes, it does. Epic. Alright, now that's cool. That's cool. We did those values, but what was the next part? You find those values, the rest of the values. From how? From just using the values you found for that step. Okay, sure. Well, if that's the case then, we can build out these last two values, which I'm going to build out on the side. So Q Messies and Q Suarez P. Messies, Suarez P, yeah, are the two that I need to do. Actually, I'll do them here if I can. Messies, Suarez P. Eric, so any other Obsidian plugins you recommend getting? So I don't recommend self-hosted live sync. I'd say try to avoid it. But I'm using it because I'm at a sunk cost right now. I mean, if you want to learn it, for sure try, but it's not. Some of it's not really that good. I use the Zettelkasten plugin or unique note creator plugin. This is just a core plugin. I use Git, obviously. So Git's also here as well. I show you. This is the Git panel, but it's not showing up any of the values that, or any of the files that have been updated recently, but I think that's a bug, but it doesn't matter. That's the Git plugin. I was probably going to suggest like Omnivore, but recently it's been acquired by another company, 11 Labs, I think. So I wouldn't suggest getting Omnivore anymore. And I think that's mainly it. That's mainly it, really. Like those three plugins. For me, at least, are the ones that I use the most. vMessy S. vMessy to shoot. Messy to shoot. And messy to Suarez to pass. Messy to shoot is a 0.2. A messy to shoot is a 0.2 and a 0.8. With -2 rewards. I'll add 0.8 Suarez and scored. So that would be Suarez and scored. So it would be -1.355 times negative 3.993. And all of that should equal something. Have you tried setting Git to auto commit every minute? Would that not be better than live sync? For me at least, that isn't syncing enough. Right? You can see how fast or fast enough this updates after I change something on the actual note, right? So it's not fast enough for my liking. Just doing Git every minute, but also you're spamming commits to Git when to your Git repository. When for me, I like to, I guess, not spam my Git history with automatic commits every minute. Yeah. And also, yeah, I think that's it. Git auto commit for notes. I mean, it's still, I did it for 1 point, that's what I mean. You know? Just make a burner account. Yeah, I mean, look, I did it on my main account on GitHub, right? But now I just made my own Git repository or Git self-hosted repository. So even when I commit to Git, I'm committing to not GitHub, but my own self-hosted Git called Git-T. So you see Git-T is what I have here. And this is gitty.local.my website. But you can see when I started doing this was back in July, so start of the year basically, or start of the semester I should say. And I'm liking it so far the way it is currently. You can see how my commits have been committing. You know, I don't do it every day. If I'm working hard, I do it 5 times a day. You know, I do provide some information on how to set this up, but this is mainly for personal, from personal experience that I just want to document. You know, if I wanted to set it up on Windows, I would just follow this. I haven't written anything for how to set it up on Mac, mainly because Mac is almost like the default spot that it comes from. And yeah. But it's also very hacky. Like, look, even for the iPhone to iPad, I send a zip archive to the iPhone or iPad, and then extract the zip archive from the iPhone or iPad. And then I would move it into an Obsidian folder on the device, and then all this stuff. Like, it's not ideal setup instructions, but I've thought about this stuff. Anyway, but yeah, Gitty is what I use for my Git for self-hosted Git repositories. And super useful, especially for, you know, Zettelkasten, which is, my notes are meant to be private and mine. So now let me do this calculation. I should expect this calculation to equal messy s, which is -4.772. So 0.2 times .772, perfect. And Suarez, well, where does Suarez go? So Suarez goes with passing, we just go to messy 1. So -1 plus 0.8 messy p. -1 plus 0.8 -1 plus 0.8 times -4.194 -4.355. Is that the answer? Yes, it is. Epic. So now we can also point this here, and point this here. Done. All the values found exactly the way we needed. Yes. Yeah, so George Vell, right? I mean, if you want to have a go at self-hosted LiveSync, by all means, right? But just saying, it did take up like hours of my time. And I don't know, like looking back, I might have just bought like Obsidian Obsidian Sync. Except I don't like to pay for things. And I'm sure, is it like a subscription? I'm pretty sure, right? Unless you buy lifetime. Wait, is it only... Wasn't there like a lifetime purchase? Interesting. Obsidian Sync. Lifetime. What is lifetime early bird pricing? I remember there was some lifetime something. I might have actually forgotten. It might not have been actually. It's alright. Maybe that's what stopped me, right? From getting the lifetime purchase. And because it was subscription and not actually just a one-time purchase. You know, I'm really into buying things that are not subscriptions. So yeah. Eric, so what are you going to use instead of omnivore? I haven't decided yet. I think I might just use the default, oh, well, not the default, the Obsidian made read it later extension. Yeah, maybe. That's one that I've seen. It's most likely that, or maybe since Obsidian was open source, maybe there was an open source alternative on the continuation of omnivore. Perhaps. And maybe I'll self-host my own omnivore. Maybe. Considerations, you know? So. Okay. So potential-based reward shaping. So, you know, this whole first problem was just to do policy updates. Alright, so policy updates. I can kind of write the entire, I guess, process for a policy update. What are the steps involved in a policy update? Solving systems of equations, for the different possible states and best action. Now, is it called best action? Yeah, I'll just say best action. Then use those. So now they're called V value. Use the updated value function to solve the other states, the other actions per state. You know, best way to show this is probably just with the slide that I just did. This was my attempt on iteration 2. Alright, so that was that. But now we're talking about potential-based reward shaping. Why do we need reward shaping? Rewards are sometimes sparse. Reinforcement learning will behave randomly. Reward shaping is a method in which we can modify the reward function to reward the action that moves us closer to the goal. Now, the potential-based reward shaping function is f s to s prime, where it is equal to gamma phi s prime minus 5s, where phi is the potential function and phi s is the potential of state s. From s to s prime, It's the potential. But why? I guess the potential always has to increase. And you're just like going further away, I guess. Example of the potential function for grid world is as follows, where it's the Manhattan distance between the current state to the goal state divided by the width and height minus 2. Interesting. And then 1 minus this value is always going to be close to 1. But alright, sure. So potential based reward shaping, still problem 2. So consider a robotic helper at a hospital that delivers items to staff. The robot is given a task to deliver treatment kit to a medical specialist in a room. The robot has to pick up the kit from the storeroom, but first has to go to the key. Has to go to get the key for the storeroom. However, it does not know in advance whether the key will be there. The robot will receive a reward of +10 for delivering a kit, and a reward of +5 for going to the room to inform the specialist that the key is missing. There are no other rewards. Consider this as the following map, where S is the starting state, K is the key rack. M is the medical storeroom, and R is the room where the store is to be delivered. So if I understand this correctly, it has to go to S to M to R. So a robotic has a hospital that delivers items to staff. The robot is given a task, treatment kit to a medical specialist in a room. The robot has to pick up the kit from the storeroom, but first has to go to get the key for the storeroom. If it does not know in advance whether the key will be there, the robot will receive a reward of +10 for delivering the kit, and a reward of +5 for going to the room to inform the specialist that the key is missing. There are no other rewards. Consider this as the following map, where S is the start state, K is the key rack, M is the medical storeroom, and R is the room where the store is to be delivered. Design a potential function for this problem. You can assume that you know the position of the agent, the position of S, M, and K and R, and you can see a variable key with a value of 0, 1, 2, where 0 indicates that we do not know if the key is in the room, 1 that the agent is holding the key, and 2 that the key is not in the room, and a boolean value med to indicate whether the agent has the medical kit. Initially key 0 and med equals to false. So you can make a lot of if-else cases. I remember this. And when you do make a lot of these if-else cases, you don't know you just need to consider each of these situations. Right, so first would be to go to the kit room if both med is equal to false and key is equal to 0. Because key is equal to 0 specifically, we want to go to the key room. So start, get the key, get the med kit, deliver the kit to the store, to the staff. SKMR. Start, can't find the key, go to the staff room to notify the staff. SKR. Design the potential functions for the case. Yeah, so this is the summary. Alright, so the agent hasn't visited the room, the agent has found the key, can't find the key, hasn't collected the med kit, has the med kit. Now if key equals 0, you do 1 minus the normalized Manhattan of the current state to k, and you do the same thing, normalized Manhattan from S to M, normalized Manhattan from S to R. Now, this is assuming that key is 1, medkit is false, key is 1, medkit is true, and then key 2, medkit is not there, so you just go to R straight away. Yeah. That was pretty fine. Reward shaping update. Okay, this is the last 2 slides with the most information. Enthusiast dev, so you're currently in your bachelor's. What's this subject about? So this is AI planning for autonomy. And so we're learning about AI agents. That was basically the first half of the semester, but then we learned about reinforcement learning agents. And you know, in a specific game. So we played a board game. We're building an agent for a board game. Now this board game's name is called Azul. I'm not sure if you're familiar, but that was the game that we played and built our algorithms around. Mine wasn't actually the best at all. It was actually probably one of the worst. But you know, we were working in the team together to build something. So, are you doing your master's in computer science or machine learning? So my master's is specializing in AI. So it's more machine learning than it is computer science, I guess. Just tried to follow the train of thought and felt like a caveman. Nah, that's fine. I could explain it better probably. But yeah, AI agents. You build AI agents for a game of Azul. That was one of our research projects. Now, you know, there were many approaches. You could do this in a deep learning approach, or you could do it very heuristic based. And it turns out the deep learning approach was what I did, but it was way less effective than our heuristic approach, which one of our other teammates did or implemented. And in the end, we just used the heuristic approach to solve or beat most of the agents that were in the assignment. So yeah, there was a whole system of agents where you had to, if you beat a certain number of them, then you'd get a certain score or a certain mark. Can't wait to go to an actual campus to study. I can't imagine learning this on my own. Yeah, fair enough. This is also why you know, I am taking masters. That's kind of why I don't think I'd be motivated enough just on my own to learn this stuff that I wouldn't have known to have learnt at all beyond just the subject title. Right, so computer vision was another one that I chose to learn in uni because, you know, I know that probably later in my life I won't even study it that deeply as I am doing now. Unless I really wanted to. So, you know, might as well do it now than never. Almost. I hope that train of thought somewhat delivers. Okay. Now this is the last 2 slides. Reward shaping update. Using the potential function, perform 2 different reward shaping updates using Q learning from state K 40. First perform for the action up, ending in state 41, then assume that the right action has been chosen instead of up, ending in state 50. Compare the 2 updates to see whether your reward shaping function has worked. Assume that QSA is equal to 0 for all S and A, gamma is equal to 9, alpha is equal to 0.2. Now, what would we expect? We would expect that if you're at K, you're going to the medkit, but why? You're going to the medkit because you don't have a key. Oh, okay, no, it has the key. You have the key already. So you have to go to M. If you go right, then you're going further away from M. If you go up, you are getting closer to M. So you would expect that up would be a higher reward than right. So at the end, S0 is a higher reward than right. But see, let's look at the steps. Width and height is equal to 8 and 6. Now 8 and 6 minus 2. Why do you do that, right? 1, 2, 3, 4, 5, 6, 7. 2, 3, 1, 2, 3, 4, 5. Yeah, okay, that makes sense. It's just like the longest distance that you could ever take between 2 points. And then you would go, so that's easily the normalized Manhattan distance. And then you'd find that to be 3 on 12 versus versus going to the right. Now you're saying S of 1, correct? He's going to the right. I guess we'll just write this down just below this. Now you're saying phi of S of 1 your current state versus your goal. You're at 4, 0. It's 3 on 12. S1 means you're 1 minus 0 minus 4 plus 5 minus 1 on 8 plus 6 minus 2, which is minus 4. 4 plus 4 is 8 on 12. 8 on 12. 1 minus 8 on 12 is 4 on 12. And 5s2 is equal to 1 minus 5 plus 5 minus 0 on 8 plus 6 minus 2. Now again, that's 12, 10, 2 on 12. It's going to be 2 on 12, and that's not what we want. Okay. Now, what's this? Compare the two updates to see whether your reward shaping function has worked. Right, that is the same as exactly what this question is asking, right? Assume that QSA is equal to 0 and all of that jazz. So given those values, S0 up, S1, ooh. It's always more nuanced than you think. It's always slightly more nuanced than you think here for these problems. Trying to think, how should I best deal with this? Right, so this is the function. We update the QSA value with this additional reward, which is equal to this value. So 4 on 12 minus 3 on 12 with 0.9. Alright, 4 on 12, 0.9, 3 on 12 is 0.05. Then you update this new value. So this is S0 up is the current S0 up plus 0.2 given here times the reward, which is 0, plus 0.05 plus 0.9 times the max of the successes action. Minus going up, which is 0 apparently. So it's 0.01. And then you would consider right. Going right, S0 to S1, you can calculate F to be -0.1. Using S0 right, okay, you find it to be -0.2. Now 0.1 is greater than -0.2, so you choose up. Okay, interesting, right? Very good, very good. This is very well done. All right, now we are done with policy iteration and reward shaping. However, Okay, cool. I think that is good. Now MCTS is another one that I have to do, but I might do after I come home from the gym. Because what I'll do is, like, if I got 5 more days, if I have 9 more eight more, then I would have to do 2 every day to be on top of things. But maybe tomorrow we can try aim for 3 and then do it faster. Save a day or 2. And that would mean I can review more again a second time over. That's big plans in 5 days. But for now, I need a break to do some MCT, to go to the gym and then come back, maybe do some MCTS. But let me think. I'm fine. What am I hitting? Let's see. It'll be shoulders and abs today. Shoulders and abs. Yesterday I did back and biceps. Do some shoulders and abs today. Cool. MCTS is the next one. We can kind of see what we're gonna get ourselves into. We gotta just have a look here. So tutorial, lunch, shower, gym. We gotta have to do now. Then perhaps come back and do tutorial 9 MCTS. Then perhaps do a Leetcode problem. Maybe not do scheduler development today. But then these 2 lectures as well. Maybe I might just do 1 or none of them today, so that perhaps if I am happy enough to continue from here, I do another tute, which is TD learning, right? Yep. So maybe I do another tutorial 8 TD learning. You could say I'm slightly behind today because I feel like I won't finish everything. But I'm also, adding these extra tasks during the day. So when I come home, it'll be around what, 5? Would it be? Yeah. I could try and do a quicker, maybe before 5 I'll get home. And it'll mean that I'll do MCTS for an hour at least, which will bring us to 6. Leetcode might even not be able to do, but it might bring us to 7. Or if it brings us to 7, we might just finish off with a lecture. And then maybe we leave that to tomorrow, right? So maybe all of these things become tasks for the evening. All right, where it just means that we might be moving this to tomorrow. All right, so maybe these are the 4 things that we do today, ideally. A yoked CS student better be scary. I mean, I've been maintaining my weight pretty, yeah, I've been maintaining my weight for the past like 2 or 3 years. So enthusiast dev, what about your sleep cycle? Recently, I think, wait, is there health on this? No. Recently, I guess yesterday I slept like 8 hours, but before yesterday, I think it was like 6 to 7, around there for the previous two or 3 days. We're gonna get better though. I'm still following this dip peak thing from an app. So right now, technically it's meant to be a dip, but I'm not seeing it because I don't feel like it's a dip. Although maybe I did feel a little bit fatigued like around the last hour. But we're going to be peaking. Now peaking is usually going to be the time when I'm meant to be learning, but you know, the thing is I'm going to be having dinner at some point during this peak. So it's interesting anyway. But I wind down starting from 8 to 10 p.m. Alright, so then the next day is just, I say 9 p.m. sleep to 7 a.m. wake up, but that's not ever the case. I always sleep much later than 9, but usually not before 12, so that's the plan. However, why is there like duplicates of this? We don't need duplicates. Maybe it's just a one-time thing. Maybe it disappears. Alright. Cool. We're just gonna go to the gym. We'll be back in, yeah, around an hour and a half. We'll try to be faster so we can get back and do more work. Alright, go for gym, 90 push-ups now. I mean, I'll do my push-ups. I'll actually probably want to do more push-ups soon. That's something to consider, because I've been replacing it with everything gym. Alright, see yous. I just checked the mark that I got, guys. I know I'm not gone yet, but I am. But I'm here. I checked the mark that I got. We got 83%. Let's go. And I did that assignment in 2 days. Let's go. But with someone else's help as well. So someone else is also in my team. But let's go. We got a good mark on that, even only spending 2 days. Realistically, on my end, pretty good. Anyway, going to the gym now. Oh, hello Clat. This is machine learning. It's related to machine learning, but it's more specifically, I guess the subject name's AI planning for autonomy. But yeah, I'm learning about reinforcement learning. And so MCTS is a reinforcement learning approach. But before I continue, whoops, I just need to think. MCTS used in what? So it's used in game playing agents. At least that's what we used it for. So, you know, you could have a board game. For our school project, we did Azul as our game. You know, it could be chess, could be any of these board games. And you want to build an agent that can play the game. You know, there's APIs for actually playing the game and everything, but how the agent is the thing, is the part of the code that we, you know, make the choices in. So this is mostly used in game-related projects, mostly, at least for me. I'm sure you can use like MCTS for more general agents that are related to, say, you know, finding the path, the best path to take. Say if you're driving a car, you might use MCTS. In terms of taking the most immediate path. You know what I realized kind of late, but companies are implementing minigames on their website. Yeah, I know. We're talking YouTube is doing it, LinkedIn is doing it. Amazon also has one. That's okay, fair enough. Snapchat filters. Yeah, you're right. I can say LinkedIn as well is also doing the same thing. I'm gonna try something. I might try a Leetcode problem right now. Just do one. Okay. I follow a structure, but tell me what it is. If I find it in Leetcode 150, then I'll do it. Okay, so I use Leetcode 150. Okay, Leetcode 2095. If it's not in Leetcode 150, then I won't do it, alright? Just saying. Okay, delete the middle node of a linked list. Okay. Versus, I'm sure this is going to be in linked lists, but it's not here. I don't think, when I've done it in the past. Nope. So delete the middle node of a linked list. Yeah, I haven't done this one. Ooh, should I do it? I guess I should practice some of my linked lists. You know what? I will do it. I will do it, alright? I will do it. Fine. You convinced me. That's one, alright, fine, let's do it. I'll say though that I need to first find the main things that I'll use. So I'll create a new file, move to a new window. Okay. This is called delete the middle node of a linked list. Alright, and let's see if we can first find the problem on Leetcode. Middle of the linked list. So this is delete nodes from linked list. Is this? No. So Leetcode hasn't done this one at all. Alright. I'll do it though. So I'll just copy this question. This problem is in Leetcode 75. Interesting. I didn't know Leetcode 75 was a thing. I knew blind 75 was a thing, but I see. Leetcode 75 is just Leetcodes 75. Array string, 2 pointers, sliding window, prefix sum, stack queue, linked lists. So you're telling me delete from, I see. Now if I go to this, can you see the solution? No. Alright, that's fine. But that's cool. I didn't know this was a thing. I did not know this was a thing. Regardless, I will they do a little cool little bit of animation. Alright, but let's do this. Okay. So you are given a head of a linked list, delete the middle node and return the head of the modified linked list. The middle node of a linked list of size n is the ndiv2 node from the start using zero-based indexing. Hold on. Hold on. Alright, so from the start using zero-based indexing where x denotes the largest integer less than or equal to x. For n is 1, 2, 3, 4, 5, the middle nodes are 0, 1, 1, 2, and 2 respectively. So input head, output removed 7. The above figure represents the given linked list. This indicates the node are written below. Since node value the middle node, which is marked in red, return the new list after removing this node. The above figure represents the given linked list, which is marked in red. But that's because I'm okay. I mean that's fine. But you know, you just need practice, right? That's all it is. Also, try not to do 2 hours. I don't think I'll even if I get to that point on a question, I wouldn't. I'll try not to spend 2 hours in total. But let's see, right? Now, some of this is confusing to me, like what even this means. But looking at the examples, they seem fine, right? So head is 2 and 1. Output is 2 because the above figure represents the given linked list for n equals 2. Node 1 with value 1 is the middle node. So node 1 is middle node, which is marked in red. Because you do say n is the size of the list. So you're not given technically the value of n. Right? You're not given the value of n. So you don't know what the list length is in total. Right, but the middle node of a linked list, sure. Would I not do this in a slow and fast pointers? Perhaps, thinking, but that's the first thing that comes to mind. But ndiv2, starting with 0, where x denotes the largest integer less than or equal to x, for n is equal to 1, 2, 3, 4, 5. Oh fuck. That's gonna start vacuuming full on. Alright, give me a sec. I'm gonna close the door here. Yes, you're on the right track. Slow fast pointer method. Yep. Okay. But the thing is, the only thing that I'm... Bro, I can relate to this so much. Bro, did you hear... You heard it. You heard it all anyway. The middle node of a linked list n is... Okay, and 0 indexed and whatnot. For n, 1, 2, 3, 4, 5, the middle node is 1, 2, 3... So the middle node are 0. And for 2, it's 1. For 3, it's 1. For 4, it's 2. And for 5, it's 2. Respectively. Alright, so now let me just draw this up a little bit. Alright, I'm going to draw this up a little bit. In the sense that we're going to get a new one of these. I'm going to copy this and just paste it as this. I'm just going to draw it a little bit. Okay, so we have 1, 2, 3, 4. We have a slow and fast. So maybe I might link this. Group selection. Okay, so slow and fast, both are at 1, maybe, so it's at 0. Maybe if I'm thinking about this problem in terms of a linked list, maybe I can say, I guess it doesn't matter, right? It's not even indexing stuff. Okay, so slow and fast. 1 is fast at the end of the list. No, it isn't. Increment fast twice. Increment slow once. Alright. If we said we didn't have 2, 3, 4 and it was just 1, right, then the fast would be at the end of the list, and slow and fast would mean that so 1 would be 0. So for n is equal to 1 being the size of the list, then you would be at 0. So that would mean you are at 0 and you would just remove this 1 altogether. That being said, your f, you would then return just an empty, you would just return none, maybe. Right? It would return none, maybe. But is that guaranteed to have the number of nodes in the list ranges from 1 inclusive? Okay, so it could be eventually none. So if it's none, then you would return none, I reckon. Alright, regardless, f, increment twice, increment only once. We have, now if 3 was the end, well then that would be it. But if it was 2, then you would, if you were cut at 2 and you can't increment f anymore, then you'd want to get rid of 2. Right, that's how it's done. If you're at 2, then you would want to return so if there were 2 numbers, say 1 and 2, the middle node is 1. Okay, so that means you do still remove s. If you're at 3, the middle node is still 1. Okay, if you're at 4, increment S, increment F. If you're at 4, then you would remove 2. And then if you're at 5, so if we add a 5, then the F, say originally starts off like this. F, S increments by 1. No, say we increment F by 2, S by 1. That's not necessarily the case. The ordering of which goes first is a little tricky. 1, 2, check, increment, increment, why is this working for small numbers? Let me go a little higher, 6, 7, 8. Bro, hold on, I know that's a Dyson vacuum. Oh man. Oh, I don't even know. I don't even know what brand it is, to be honest. Alright, let's see. Alright, let's see. I'm still trying to wrap my head around myself, so move 2, check, possibly, move S1, move F1. Now that would be still true. Move F1, move S1, that would still be true. Move F1, now you wouldn't move S, right? Because 6 in the middle is a 3 or 4. Definitely when you move this further out, 7 is definitely not, S is definitely not the middle of 7. So keep on thinking. I think I'm close to the way that it's meant to work. Alright. Slow and fast pointer. 1, 2. One, check. 1, 2, 1, check. 1, 2, 1, check. 1, 2, 1, check. Now, if you're odd, alright, so if you're even, right, you have to determine. So that's fine for the small pointer, but for the fast pointer, 1, 2, 1, check. 1, 2, 1, check. 1, 2, 1, check. And 1 can't go anymore. Then you would just finally remove 4. Right? I think that's how you would go. But it's removing the third and not what I'm thinking. So I guess you just return the S plus 1, maybe. Alright, so let me just try it. Alright, let's try it. So slow equals 0, fast equals 0. Now actually these will become nodes, so for now maybe we'll just call them none. And we're saying the head of the linked list, we're gonna say while fast is not equal to none. So it's just ensuring that we're not at the end of the fast pointer. We want to slow equal to slow dot next. Now that means that this would have to be set to the head. So would the fast as well. Alright, now slow is slow dot next, and fast is equal to fast dot next but you need to ensure that that is possible at all, which means that if fast dot next does not equal to none, then you would be able to increment fast. But if it is equal to none, then you want to break, right? Fast next is equal to none. That means your fast pointer here is here currently. You're gonna have this fast. The fast next is none. Means you can't increment one more. Okay, fast next is none as if 8 doesn't exist there. If fast next is none, that would be fine. You would break out of the loop, but if it's directly next is equal to none, right, so you would just go like this. You want to increment S to 5 and then return S. Slow increments by 1 and return, so we're returning what? The slow pointer with what are we returning exactly? Yeah, we're returning, okay, we're removing the slow pointer. So we can just say we return head, but we know we have to remove slow pointer. Remove slow node. Now to do that, you're currently at slow, the value that you want to remove. Slow on next is the value you want to add to some temp. Now that means you have to keep track of prev as well. Now the prev is going to equal to none at the beginning, but that means the slow has to equal to slow, and then slow equals slow next. So temp is this, prev dot next is equal to slow dot next, so that's temp. Does that really change things for me if I just go like this? Slow.next, prev.next. You don't necessarily need to go the other way around, right? I think that's fine. I'm trying, we'll see. Right, slow increments by 1 is because we're doing slow equals slow.next. I just clicked ChatGPT. Let me go back to this. Alright. Non-type has no attribute next for sure. Prev equals slow. We will have to check what the value of prev is after every iteration, just to see. Prev.val might not exist, right? Which one you prefer, Codeforces or Leetcode, and why? I haven't tried Codeforces, but Leetcode is my go-to, so unfortunately I can't really tell you. And also, there's also something called HackerRank. Like, I feel like they'd all be pretty similar, right? Maybe check if prev exists after the while loop. If I do that, just do it for checking, right? This won't really tell me much, like non-type has no attribute next. Are we saying that the slow is the problem here? Because prev exists. Yeah, anyway, so that, I think it is slow then. Which means to me that print slow is what we have to do here. Just to see what that is. It's none. So slow value wouldn't have anything. That would be the issue. And okay, now let's then try and go through this with the example of 2 and 1, right? So if your fast is not none, they're both at head, then your previous is equal to slow is equal to 2. Slow dot next is gonna now equal to 1. And if fast dot next is not equal to none, which it isn't, then it would equal to none. And since we already did slow dot next once, we don't need to do it again. Output is 2. Output is through expected 2. Output is 4 and 7 when you expected 3 and 4. So I removed 3 when I was meant to move 7. Alright. I was meant to remove 2. I was meant to remove 3 when I was meant to remove 2 when I was meant to remove 3. Okay. Let's print the slow value and the fast value. Right. This will help just to understand what's happening. So 1 and 1. 3 and nothing. No. So it only outputs 1 and 1. Is equal to none. Right, fast dot next. It's just fast dot next. It actually doesn't matter what it is. Almost. We removed 1 ahead. You expected this, but you didn't remove 7. We're close. I might move this more, it makes more logical sense to move it underneath. So slow values, so 1 and 1, 3 and 4, 4 and 1, 7 and 6. Now that you're at 7, prev.next is equal to slow.next. Now, if I delete this, paste it under, all right, I should see a similar thing. Okay. That was because fast was none. Hello? What was the difference? Wait, what? Was it the prev? Yes, it was. It was the prev. It was the prev. It actually was the prev. Wait, what? Okay, wait, so it passes the runs. Alright, it passes these ones. Wait, what did you delete? So I deleted a print statement. Or I moved the print statement after, and then I moved it back to before, and then that was the difference. But no, I was also moving prev here. So prev was before this, but prev is now after this. Which makes a big difference actually, now that I think about it. But, you know, my thinking is also now like, why doesn't this work? Because prev next, slow next, prev next is none when we can make it a dummy node, right? I think we can make it a dummy node. So list node 0 next is equal to, I guess we can just write head, and then prev next, and then we can just say dummy dot next, and that means we change this to dummy. Whoops. And we can get prev equals dummy. Yippee! Alright, but that took, okay, sure, runtime is low. And space complexity is okay, I guess. But runtime is low for some reason. Thank you, Clat. But this runtime is still low, like why? Is it because I could do something else better? Let's have a look at some of these solutions maybe. So it was a fast and slow pointer. Okay, this is done in Java. Whoops. Java solution, Leetcode, intuitive approach, easy Python. Maybe I'll just do Python 3. Okay. So the runtime 3 milliseconds. What's the idea? Okay. Alright, let me take this blower. So initially the list looks like this. Initialize pointer as a dummy node, prev is created, and its next is pointed to head, slow is pointed to prev, and fast is pointed to head. Okay. Traverse the list, so moves one step at a time, fast moves 2 steps. The goal here is to have slow point to the node just before the middle node by the time fast reaches the end list. Okay. And by the way then, you know, this is the target that we want to remove, but slow is just one before the target. In the third iteration, fast will be null, and the loop terminates. And this is where you would return, okay, so you would still remove 7 here. Delete the middle node. Is the middle node 7, so we get slow next to slow next. I mean, I said... Okay, return the modified list, we return next prev. Prev next, which is the dummy node. Alright, bet. So he's done it differently to how I've used prev, but cool. The obligatory standing kitten at the end of every post. I don't know how to upvote posts, so don't worry about it. But we can add this here, so solved problem using fast and slow pointers. The way to create I guess the way to keep track is to use the slow pointer. It doesn't matter how the slow pointer I guess it doesn't matter the shift of the slow pointer. But I had to use a prev node in order to remove the delete the middle node. Now when you could just slow equal to slow.next. So that's the way that the solution's done it. They just want upvotes for Leetcode coins. I see. I didn't know how. I don't know how. Leetcode coins so you can get that Leetcode cap and that Leetcode merch. Oh, that's crazy. That's kind of funny. And it's what the grind makes you... That's what the grind makes you become. A shill for Leetcode. Okay, but... maybe that's why my efficiency was slower, because I was always defining a prev. Now if I changed it so that slow pointer pointed to... Can I change this now? So I'm going to say instead of using a prev, slow.next, prev slow.next and slow is at dummy. Prev then here doesn't exist, but we got a dummy. What's happening here? Oh, whoops. Slow.next. Okay, so that did it. Okay, there we go. Now we're within the correct milliseconds. All right, now that was the optimization that we did there. All right. You can also unlock content with the coins. I see. Well, really, you want to spend more time on Leetcode? I suppose some people love the questions, I guess. Okay, but that was the optimization. And I can probably just copy and paste. So, Python. Okay, that's a problem. We gotta open VS Code first. Why? Because it formats it properly. So if I copy like this, paste it. Okay, never mind. I need to get rid of something. Something's up here. Oh, it's just slow. That's what. Okay. Okay. Is it even? I don't like that. There we go. Okay. So that was the optimization. And original solution. The original solution was what app is that again? The app that I'm using to write these notes is called Obsidian. Okay, I think this was the solution that was longer. Let me just run it. How come it's just like accepted now at a somewhat reasonable solution time, runtime? Was I really just unlucky before? Maybe. Or maybe, yeah, what I'm saying is just it doesn't matter then. Oh well, I mean, you do remove the need for prev, I guess. So might as well copy this. Just do it. Okay, optimized. Yeah, runtime is just random, most likely. Alright, but that is the problem done. And yeah, that was pretty fun. Not gonna lie. Can you link your Leetcode profile? I don't know how. Except just going to it. There you go. That's the link. Have I been consistent? How come I'm missing like the 1st of November when I did do it on the 1st of November? Like I'm basically doing it every day, but it's becoming a checkered pattern. Do you have more on Leetcode 150? Yes. I still have a lot more. That's what I'm talking about. Look, say I've done all the linked list questions. I'm almost done with backtracking and tries. Okay. This is my progress. So except yeah, I don't know why it's still somewhat off sometimes. 83 versus 85. I think I must have skipped some array problems. When I first started this like 8 months ago. and I was doing it on and off. Alright, but Alacrity, we've got to save this to our Leetcode repository. Leetcode in Vim. This problem is called delete the middle of a linked list. 2095, delete the middle node of a linked list.py, and we copy the solution, paste. Okay, I think that's right. Git commit, git add, git commit. Solved linked list problem. Solved problem, solved by myself without looking at Solon. Git push. Bro is farming commits. Ah. Alright, git, and we can just exit. Alright. Not bad, not bad. Not bad. Alright, so we can close this problem now. We can close this as well. Now we can tick off Leetcode, and we have a choice. Tutorial. Schedule a develop? Probably not. I think I'll just do tutorial now. I'll just do another tutorial. Man. Alright. Now it's time for the more brain intensive shit. Not that Leetcode wasn't already, but it was more like it was brain intensive in the sense that I need to make sure that movements of each of the pointers were right. Leetcode a day keeps unemployment away, exactly. That's how it is, that's how it is. I've recently also, like last night to this morning, I was editing my resume as well. From some feedback that I got from people on this OzDevs Discord, I got some feedback from them. I made some updates to my resume. And hopefully it should be better now. Dummy. Full screen this probably now, I think. Because yeah, another page. We could open APA. GG. Void, hello. Welcome. MCTS. Alright, Monte Carlo tree search. Compare and contrast online and offline learning. What are you working on? I'm working on I just finished Leetcode. A problem that Clat recommended, and then now I'm just doing MCTS. Relearning MCTS for the exam. Oh, nice. When's your exam? It's in 5 days. For this one that I'm currently learning is in 5 days. The next one after that is in another 4 days after that exam. So we're looking at 9 days for that second exam, and 5 days for this coming exam. You work out? Yes, I try. Today I did what's it called? Shoulders and abs. So my shoulders usually after it do get strained. What is the difference between offline and online learning? Which does MCTS use? I'm saying MCTS uses online learning. Alright, I think I know that much. Next void. And CLAT, so you do calisthenics workout. I see. You must get that what's it called? Physique. Right? Some good physique there. I honestly, personally want to try doing more calisthenics. Just because I think generally the physique looks better. Like looks better. But also you are technically stronger. More flexible. More aerodynamic. Maybe. "30 push-ups, normal, diamonds, wide. Diamonds, normal, wide. 3 sets each. 3 sets each. So you're talking 90. Wait, so at a minimum. So wait, 30 push-ups. 3 sets each. Means 9 times 30. Okay, 90. Okay, 3 sets. I see. I was going to say 3 sets each is going to be quite a bit. 60 dips, 60 squats, 60 sit-ups, 30 bicep curls. So I'm guessing you would have actual dumbbells there. Not dumbbells, what are they called? Nah, you know what I mean. I don't have the bicep curls tools. Fuck, what's it called? What are they called? So Kanishka. So you never used Obsidian. Is it similar or better than Notion or other note-taking apps? Personally, I'm using Obsidian for personal note-taking. Notion I would use for teams, like when I'm working in a team, because it's just simpler. And I would only use Notion over Obsidian for its databases, if I ever use databases. And that's it. So CLAT, that's your morning workout. You usually finish in 30 minutes. Yeah, nice. Honestly, I might want to try and do that when I'm at in Sydney. Yeah, honestly, like, yeah, that's what I'm thinking also. I'm only... The reason why I'm at the gym still is because we have, I have a friend who also goes and we go together. But definitely, like when I'm in Sydney, I probably will just do workouts like what you might be doing. Honestly, I'm just gonna copy your routine here. Seems like good enough to me. You know what I'm saying? You know. Copy it over. This I'm gonna put to preparing for relocation and move to anytime. All right. Thank you, by the way, Clat. The 60 is divided in 20 by 3 sets. I see, yep. That's fair. Just keep it there. I'll just keep it there. Okay, online learning. An action is selected online at each state 1. Once an action is executed, we start planning again from the new state, MCTS. We need access to a simulator that approximates the transition functions and reward functions of our MDP. The simulator allows us to run repeated simulations of possible futures to gain an idea of what moves are likely to be good moves compared to others. We solve the problems offline for all possible states and then use the solution and policy online to act, e.g. value iteration. One success story I want to share right now in terms of my studies so far. There was this assignment. All right, it was a group assignment, group of 2. And this was for computer vision. Okay, in computer vision, this was our final research project. So this is the most time that you are given to start on a project. And it pretty much started in week 6. Right, week 6 of the 12 weeks that we have at uni. So this final project, during all that time, I kind of procrastinated it quite a bit, to the point where I only had a solid 3 days to do it well. Now, I was fortunate enough to have my partner, who was on my project partner, also just do some of the work. So he did good work that I could continue on writing from. And what we did get as our final mark was more solid than I would have expected my 3 days hustle to have been. Now I'm about to go and eat, but let me finish the story. The mark that we got was, let me think how to actually share this. I think probably see it here. 3 out of 3 points for the code. All right, 3 out of 3 points for the code. The report, 20 out of 25. Let's go. Now, like, you know, this is total. In total, there's 30 marks because there's another 2 out of 2 points for teammates marking each other. So if your teammate, like me, literally procrastinated until the last 3 days, you might give them 0 out of 2. But I got 2 out of 2 for that, so I was fine. But in total, this was a points out of 30 marks. Now, you know, these points directly relate to the final subject mark. So we're talking, this is 30% of the entire subject. We only lost 5 marks, or 5%. I'm pretty happy with that, given the amount of time I spent. Wait, before you go, what are you eating? I'm eating rice, most likely, because mum's cooking, but it's rice. Usually we have like this minced meat beef with capsicum, and sometimes there's like tofu, so it's all pretty tasty. Anyway, I got my signal to come over. All right, but yeah, so look, we did pretty good, it seems. 4 out of 5, 8 out of 10, 7 out of 5. Look, I gotta read these comments better, but like, this was our work. My partner literally worked on all of the explanation and approaches section. So he tried 2 different approaches, and then I did the experiments and results. Now, basically I did 1.5 pages, whereas he did all of these other pages. So I did from experiments and results, I actually did these experiments, tried it among different parameter tuning values, hyperparameters I mean, and we got a final of 63.125% correct, with just a generic conclusion, but limitations as well was actually one of a good discussions, I think. Regardless, it was pretty good. All right, Clat, good night, man. Hello, Prayash, by the way. Yeah, Prayash, I'm about to eat, so I'll see you in a bit. All right. I want to read some of this also at some point. All right. Be back. Alright, I'm back. So go check over Discord. It's got a few chats going on. C++. Alright, bet. Alright. At the very least, I should finish MCTS. Let me have a think. Check. C. I'm gonna stand. Abhishek, can you please solve a Leetcode problem? I want inspo. Well, the thing is, I'm done with Leetcode for today at least. Come back tomorrow. Or watch the Leetcode that I did a moment ago with Clat, if you wish. Only down has been expanded from the root node, and q 1 down is equal to -1. q 1 down is equal to -1. And n 1 down is equal to 1. Why? Void, you were just reading about networking, it's so cool. Hell yeah, it is. Which part of networking? I have learnt about it. In terms of, say, the TCP protocol, the HTTP, I guess, scheme, the structure of the internet, how there's wires literally going under the sea, reaching other nations. And yeah, the OSI model, right? Of course, yes. TCP IP. You know, there's a bit of SSL that you will learn as well. I'm not sure if you've gone up to that yet. Where did I learn it from? I learned it from a uni course as well. So for me at least, it was part of computer systems as a subject. Alright, it's called computer systems at the University of Melbourne. Technically that taught me about more than just networking, but also computers in terms of the OS. You know, kernel level and user level modes and whatnot. Same thing with like RAM and all the I guess parts of a computer. Yeah. Q and N. Estimate reward. Number of visits, I see. Deterministic action. Simulate -1, simulate -1. Left 1, up right. Simulate 1. Up down, simulate 1. So up right, so up. That at 2-1, what is the best action? Deterministic action. I should just zoom in a little bit. CS too good. Yeah. You're glad you have the passion, man. Same here. You just realized you haven't subscribed? God damn it! What you doing? Why not? Why? It's not like I tell you to anyway. It's not like I tell you guys. Okay. The notation simulate G means having just expanded a node, simulate from the outcome to receive cumulative reward G. Ah, yeah, okay. Yeah, I'm back. Blocks, Hub, Roblox. Hello, I'm back. I'm going good though. Alright, all good, Void. See you later. So what are you doing here? Can you please describe in short? Yes. So for me right now, I am learning about MCTS, which is shorthand for Monte Carlo tree search. And this Monte Carlo tree search is an algorithm that plays games. Now in this game, we have a grid and you want to move to the +1. Now, the way that you analyze how to do that, well, you have to consider where you're currently at and how to get to that point. Now, the agent or the MCTS algorithm will know exactly where that best place is, right, in that top corner. It just needs to search through its potential actions, say moving left, right, up and down, in order to reach that spot, that +1, which is their goal, right? And so, you know, all of these algorithms have some sort of goal, and the only way to reach the goal is through simulation or understanding the problem and moving to that spot. Only through analyzing where they currently are at. So in this case, the point is in 2-1. Hope that makes sense. Ryo, so hey, hope you're doing well. Very random but generic question. How do you manage your study time and what do you probably do in your free time, if you don't mind me asking for sure? I'll answer that. So for me, at least, my study time is, I guess it varies. I try to do it flexibly. Like right now, I'm already feeling a bit fatigued, but usually what happens is I do some in the morning. I guess, you know, morning is the most fresh that anyone can be. And then during, say, around 12, I would go to the gym, you know, just roughly, right, most of the time. But more recently, yeah, I've been going to the gym roughly 12, eat lunch at 12, have a shower at 12. But that means in the morning, I spend maybe 2 hours learning well, 2 or 3 hours learning well of whatever I'm learning. And then In the afternoon, I should be fresher after the shower, after the gym, after the lunch, and I can continue again, right, and do some more. That's how I generally tackle things, but I think sometimes you can also like sprinkle in some study. Like even when I'm going to the gym, I could sprinkle in some study if I really wanted to, but most of the time I haven't been that motivated to do that sort of stuff. But in terms of my free time, you know, usually say it goes from 9 a.m. Say my study or work day goes from 9 a.m. to 7 p.m. I would spend the rest of the time sleeping or just chilling, right? Just chilling. I mean, yesterday I was kind of doing other miscellaneous tasks. I haven't been playing any video games recently. You know, I dropped Valorant for a bit now, for a bit of time now. And sometimes I'm just like rotting away watching YouTube videos. But more recently also YouTube videos have been somewhat bland, not really to my tasting, so I haven't really been on that either. And then, you know, there's the what's it called, the Reels and the TikToks or whatever. I sometimes guiltily fall into the trap of, right? But I can't do that during the day. I've made that into a habit, which it's just like, I don't do it during the day anymore. Because look, we got a camera here. This camera is literally my phone. How can I do it if I can't even take my phone without punishing me in the sense that I don't have a video feed to show people who are watching me, right? So I don't do it during the day anymore. I mean, when I'm sleeping at night, just before bed, I might get stuck on it, but I try not to as well. Then, you know, there's also just being with friends and stuff as well that I need to do more of, especially after exams, you know. Once we're done with exams, I've got to meet up with a lot of friends, catch up with them for the amount of time that I actually missed, and we'll be good, you know. I think more recently, you know, there's been a lot more boredom in my life, but I think that's healthy, and a healthy amount of boredom. Pretty same, I guess. I've just been reading mangas in free time or just going through some interesting topics to read. Thank you for answering. All good. Yeah, I mean mangas. I haven't read any, but that's the thing. I actually think like you know, maybe I gotta find something that fills up my time more rather than TikToks and the Reels or whatever. But the only reason I go on Reels is because I want to keep on top of like a specific club that posts on Instagram at my uni. And that's about the only time that I actually want to go on Instagram. But yet again, I would still feel some sort of FOMO if I do. So I try to limit that too. Anyway, you're welcome. select 2, 1, expand up, expand right and left, but you don't do down because you already did down. So if you expand up, do simulation 2, 2. Yeah. Simulation. Backpropagate the reward at -1. So if you have a -1, and 2, n equals 2 on the root node, and q of 2, 1 up is -1. And n of 2, 1 up is 1. Okay. Okay. Light's Labyrinth. How do I improve my problem solving? I did 100 Leetcode problems. Well, I guess my question is, do you feel like your 100 Leetcode problems has been helpful to you or not? I mean, by your question, it seems that you want to improve your problem solving? Because maybe the 100 Leetcode problems didn't do enough for you? I'm guessing. I see. You mostly struggle in graph and DP problems. The rest is fine. Well, that's okay. Right. It seems to me that you're probably learning all right. You know, for me at least, the graph problems, the DP problems, I'm not fully up to there yet personally, right? The graph problems, I've done some. DP problems, I've done like 2 or 3. But in general, you know, I guess the problem solving that I've done here, how I would just say to improve it for me personally would be just to write notes after you do a Leetcode problem. Every time you complete a Leetcode problem, like provide the way that you solve that problem. Write it in your own words, right? Make sure you can understand that problem to enough depth. The understanding of the actual data structures to enough depth that you can just bring it out from your head. And, you know, you might not bring out the exact details, but a general 1-sentence explanation of the approach might be a good thing to have. Okay, that's how I would improve my problem solving. It's just about making connections in your own brain, I think. And then you should be able to pick up the patterns, is what I'm thinking. Like, I mean, for you at least, you know, graph and DP problems, you probably just got to do more of them and make sure you kind of like summarize what you've learned from doing each of those DP or graph problems. That's what I'm thinking. Hope that helps. So blocks, can you help me with one thing? I'm a full stack web dev, MERN stack, and mobile dev React Native. So I know basic, intermediate DSA to solve problems and optimize queries and API. Should I learn deep in full stack or go for DSA to optimize and make better algorithms? So for me personally, I would say, because, okay, so you know full stack, you know mobile dev, but you're thinking, do you want to learn deep into full stack or go for DSA deep? I think you kind of need a balance of both, right? And it depends on what you want to do in the end, really, right? I would, I mean, what type of optimizations are you thinking in terms of DSA? Because I would personally not want to reinvent the wheels in full stack apps that you're building. It's a bit confusing, like in future it's Web3 and AI. Right, so if that's your concern, right, to build in Web3 and AI, you would probably just need more technical understanding of, I guess, back-end related stuff. So I guess you could say you would need to know more DSA, but DSA isn't really connected that much, but is I guess a foundation to AI, right? And Web3 stuff as well. But mainly for Web3 stuff, I would say they're more related to designing and creating protocols, which in this case is more related to backend in a sense. So it can be require optimized, but also more better algo. Yeah, so look, I would just say, like, if that's your concern mainly, then I would say try to have your DSA fundamentals down, but it's not necessarily the only thing that you need if you want to build out, better algorithms. If you're particularly interested in building out algorithms, that might be some theoretical, PhD level stuff that you might be looking into in computer science. You know what I mean? Otherwise, most of the stuff on the web, I guess most of the optimizations of certain algorithms you can probably find on the web. That's what I'm thinking. All right, hopefully that somewhat gives you my take on it. Anyway. Okay. Now, okay, so we did right. N is 3 now. I am pretty sure. So I'll write this in. And then n is equal to 4. I think. Up though. Okay, left actually. I'm going to talk about left. So that's going to be 4. Right, so then we have n equal 4. Okay, now this gets messy. Backpropagate the reward 1 for what? Alright, iteration 4. Iteration 4. Why is there a G there? What does the G mean? So say that's your equation to update the QSA value. QSA, state of action, Q. Q is equal to it's just the updated Q value. An updated Q value. If you're doing upright, up, right, up, right, N22R is equal to 1, Q22R is equal to 1, but Q221 up. So N is going to be 2, but Q is going to be 0 because of this function. N21 up is 1, so wait, it's not 1. 21 up is 2. I guess that's you update N before you update Q. So if that's the case, yeah, sure. 1 on 2, so you update N before you update Q, right? I guess I should write that down. Fair enough. Now use this equation the reward is 0 at 2, 1. Plus some G value, the G value is 1. Okay. Yeah, the simulated value. Now why is the gamma 1? Is that just by definition? Doesn't say. Minus the previous value being -1. Gamma being 1 is intense. But we'll just point to it. Okay. Now you do it for up down. You get a simulated 1 Okay, and then 2 becomes 3. Then UG is 1. Which then 2 1 up is 0. Camera is still 1. R is still 0. So you'd get 0.33. 2 1 up, 0.33. Okay. Cool. I mean, that seems valid enough. You take the maximum value left. So, right. Left would be the best value. Okay. Let me sit. Damn. Lights Labyrinth. Is this your assignment? This is just tutorial questions. So because I'm reviewing for an exam, I'm just going back over the tutorial problems in the hopes of understanding, you know, all of the problem's content, as well as doing the problem, right? In this case, I'm kind of almost relearning MCTS as well while doing the problem. And that's the main, I guess, goal of mine in preparation for the exam. Alright, I gotta try something. Okay. Okay. Action left. Okay, and the upper confidence bounds. The action. And then upper confidence bounds. Or UCTs, upper confidence trees. Based on your tree, which of action, north, south, east, west. Okay. One thing I do want to say is each node has a Q and N. Per action. I think that's the way to think about it. Okay. Alright, this will be the last part where I need to learn, and I'm calling it a day. But, so I will say this will be done. That would mean we still have an hour, most likely, to do one more. But these will definitely have to be done tomorrow. This can't be done. Be done tomorrow. Alright. Alright, upper confidence trees. Exploitation. UCT. Based on your tree, which action exploration, exploitation, exploration constant. -1, 2 times a half, to ln 6 to ln S6. Now, this has to be for the current node, 2, 1, of course. Now you choose, that's for down. You got to do left, up and right, right? So for down, that's 0.89. For left, times 6 divided by 1. And 1 and L. That's here, right? It is. Was it a -1? No, it was a 1. Number of times, only once. But it was 1. Okay. Okay. And then up and right, similar situation. Very true. Now was that 3? Because 3 times? Yep. For the 2, 1 up. 2, 1 down, left, right. And 1, 3, 3. Cool. So it is what we think it is. All right, and that's it. That's the understanding of upper confidence trees. Game theory though. Okay. Cool. Gotta check out. Ooh, what's this? I'm getting sidetracked a bit. Where should I save data master? On array in client-side React. Or database server side Firestore. What is data master on array? Where should I save data master on array? Where should I save data master? I mean, it depends. Like, what is a data master? I think. Yeah, that's what I would think. Alright. However, main objective was to check ed. Alright, can't say I know. Right. Mark on red. Alright, we're calling it a day. No, maybe we can do one more, because there's also a lecture. We could watch parts of that. Since it's also, yeah, why not? We'll just start on it. So I'm gonna have to end the lo-fi and go to the lecture. All right.
This material is more in.
Where are we? 12:05. Let's go there. Okay, so they should be visible now, I hope. Yeah. Oh, it would help if I plugged back in, wouldn't it? There we go. Okay, all right. Hello, everybody. We are almost there. So today we have the final set of slides for object detection. And then I have a slide deck which I've just put on LMS but is not examinable, and it says so, about diffusion models and how they work. Because having done GANs, and GANs are no longer the principal way we do that, I figured I would explain to you how we do that. And then there's a little bit of stuff in there that the Chris's and my student did a year ago, which is worth telling you about because it's cool. Okay, so recap, where are we? We were talking about how to evaluate object detectors. We went through the matching algorithm where we find something, we start with our highest confidence detection, proposed detection, see if it has a high IOU with a piece of ground truth. If so, that detection claims that bit of ground truth and we remove it from the pool, then we move to the next high detection and so on. If we don't have a sufficient IOU, more than 0.5, in the case of the mean average precision score, then we mark that as a fail for that proposed detection. That ends up giving us a precision recall curve. So the first two were successful, so we have 1 out of 3 detected at 100% precision, 2 out of 3 detected at 100%. With precision, then we had 2 that were unsuccessful, bringing us down to 50% precision, 2 out of 4. Then finally, the 5th one was detected, which brought our precision up to 3/5, 60%, and completed our recall. If we had not detected that one there, and we didn't have this point, then we'd actually draw a line diagonally down to measure the area under the curve. To that point there. So that's the area under the curve we do have. So we join the first point across to the 0 recall, 100% precision point, and we connect the last point to the 0 recall, the 100% recall 0 precision point. And then we can measure the area inside this shape, the area under that curve. For mean average precision, we get that average precision for each object, an average. For the COCO version of mean average precision, so this is using an IOU of 0.05 here. Whoops. For the COCO version, we repeat that with the IOU threshold being varied between 0.5 and 0.95 in 0.05 increments, and then average those. So we can have various mean average precisions for these three classes, that then if we average those, that we get the mean, we get average precision for these, which are the area, it's the area under the precision recall curve. Averaging those gives us the mean average precision. The COCO variant repeats that whole process with different IOU thresholds, and then you average all those. Okay, so we use mean average precision or COCO mean average precision to evaluate object detectors. We can't do, these things both require two steps. They require a non-maximal suppression step and they require a precision recall curve step. That requires an IOU threshold. Changing that can make a big difference. And it's actually, 0.5 is surprisingly high. The two bounding, if you set your threshold at 0.5, you find the two bounding boxes really have to look very similar. It's not as permissive as the number sounds, because you can have essentially, you know, one quarter of the union is outside the intersection, but in one of them, and 1/4's outside the intersection and then the other. So that intersection for each of them is 2/3 of the whole thing. And that's still only a 0.5 IOU. And we made the point that one number is not very informative, so it doesn't actually distinguish between these different kinds of errors. Is the object classification really bad, but the bounding boxes are great? Is that good, but the bounding boxes are terrible? Are we getting lots of things but missing others? Are we making, you know, detecting too many things so we get everything but our precision is low? So there are false positives, false negatives, and exactly what defines a false positive and a false negative depends on things like choice of the IOU number. So it's a complex area is the message I am projecting. The last thing I want to do here is to talk about the role of context in understanding what things are. So this is our scene. If we're in this scene, it's a coral reef, there are fish. We can expect, that gives us a really strong prior on what things are. So here is an example. These are slightly blurry images, but the information is kind of there. So who is going to volunteer for me what they think this object, this dark blob is? Right, good. And this one? Okay, and this one? Excellent. Really good, thank you. Of course, it's a trick. These are all the same pixels. But thank you for participating, I appreciate it. Okay, so these are actually from the car. So the second one, you were absolutely right. But the left-hand one and the right-hand one are just those pixels transposed into the scene. That was mean, I apologize, but it tells us something helpful.
Make a video on the right as it's overlaid by chat. Yeah, the thing is though, doesn't matter because you can see the scene anyway here. You know what I mean?
Conversely, I give you here some pixels, and if you kind of squint at it, you can probably, it's kind of easier for me because they're just giant there, but I can see what some of those things are, but it's not 100% obvious. But if I show you where they came from, then you can tell me unambiguously what all those image patches are. Okay, so we have a car, we have a pedestrian, sorry, yes, that side, the pedestrian. Up there, that's foliage on a tree. Down there is road surface. So context can tell us a lot of things, and a lot of our deep learning systems, of course, take advantage of this because this is why you need a receptive field that's larger than just the object itself, because what's happening around the object tells you a lot about what the object is. Okay, so we get global priors. This is an underwater scene on a coral reef. This is a street scene. You get local priors. This is sitting on a desk. That tells us about, sorry, the global prior here is actually just the prior, apologies. So what's the chance of that object actually appearing? And then there's what is it likely to be given the location? So this is the context, local prior is the context sensitive prior. Can reduce false detections, but, okay, what goes wrong? If I include information about the context, if something is out of context, then I'm likely to misidentify it because my prior is sending me in one direction, but actually this is something that's out of expectation, and so I need to be able to encounter new things. So I might say, well, you know, knives and forks and spoons, it's likely to be a kitchen, but actually maybe I've never seen a picnic before, so this is an outdoor scene, and I might say, oh, or the system might estimate the probability of things like knives, forks and spoons is really low in an outdoor scene. But I'm exposing it to a new experience, which is a picnic, and that can lead the system astray. Okay, we have modeled object detection as patch classification. Those patches can either come from sliding windows, that's expensive, or it can come from some proposal mechanism. And we've covered a whole bunch of proposal mechanisms, and then things that turn those patches into classifications and give us accurate bounding boxes, and even paint the pixels inside the window to tell us which pixels belong to the object or not. And those systems that we looked at, the RCNN systems, are just taking pixels that are near neighbors of the object, a close surrounding of the object, and we ended up making the point that actually the whole scene may have a lot to tell us. And so some systems actually compute some kind of gist of the scene, and then that gets fed into the classification for any particular object within the scene, for example. But we didn't give you any examples of that. Okay. So that brings us to the end of the examinable material. Yay us. So I'm going to talk a little bit about diffusion models. Right. So I made the point that generative adversarial networks were really a breakthrough technology.
So since this is like unexaminable stuff, I might start watching it tomorrow, and we'll say this can be continued on from tomorrow. We can plan our tomorrow a little bit. So planning being tutorial 8, tutorial 7, and tutorial 6. I'm gonna try do 3 of them tomorrow. So ideally, these can all be done, and hopefully the 2 lectures for CV, which then would count me done with all the lecture material for computer vision. With that, is there anything else left for me to think about? I think I'm fine. I think we're going to call it today. That's going to be the end of today's stream. Thank you for joining and being alive. And yeah. All right, guys. I'll catch you guys later. Peace.